Hello again. Here is a short video explaining the working of an antacid called Ranitidine. The commercial name is Zantac. This was synthesized or manufactured by Pharmaceuticals. It was first synthesized by an English chemist called John Bradshaw in the summer of 1976. And this was made for the first time at Pharmaceuticals in the UK in the summer of 1976. So before we understand how ranitidine works, let's try to understand how acid is produced in the stomach. So I borrowed this image from Johns Hopkins University website and it has been referenced here. So this is the image, this is the stomach, and as you can see here on the outer surface of the stomach you see the gastric glands, and a section of the gastric gland has been magnified here. So for the acid to be produced, three things have to happen. You need histamine, gastrin, and acetylcholine. These chemicals have to bind to the outer surface of the parietal cell. The parietal cell is the stomach epithelial cell. They're usually present on the surface of the gastric glands. So again, a parietal cell has been magnified for you here. So when three of these chemicals, histamine, gastrin, and acetylcholine, when they bind to the outer surface of the parietal cell of the stomach, then acid is produced. But it's a lot more complex than actually is. So let us take a look and understand how hydrochloric acid is produced. Let's say that's my parietal cell. Excuse my drawing. So once these three chemicals, histamine, gastrin, acetylcholine, bind to the outer surface of the parietal cell, a series of reactions happen inside the parietal cell. So the first thing that happens is water and carbon dioxide combine to produce a carbonic acid. And carbonic acid, being a weak acid, it's unstable, so it dissociates, breaks down to hydrogen ion and bicarbonate ions. And this bicarbonate ions simply diffuse into the blood or the bloodstream, and in exchange there is a Cl- ion entering the parietal cell. And once the chloride ion enters the parietal cell, something else happens. So then let me draw another parietal cell. So let's say this is the same parietal cell. In the next stage, let's call that as a parietal cell. So inside this parietal cell, once the bicarbonate leaves the cell, we have H plus and Cl minus, because the bicarbonate left the parietal cell. Now what happens in the next step is, so you have an enzyme system, H plus potassium ATPase. So this enzyme system, this is how it works. So in the next step, the hydrogen ion leaves the parietal cell and enters the gastric glands of the stomach. And once the hydrogen ion or the proton leaves the parietal cell and enters the gastric gland, so that is exchanged for a potassium ion. A potassium ion takes its place. So hydrogen ion leaves the parietal cell to the gastric gland, and a potassium ion from the H plus potassium ATPase enzyme system takes its place. And chloride ions, they're greater in concentration in the parietal cell. So you have H plus here, and the Cl- ions also simply diffuse from the parietal cell into the gastric gland, where they combine to produce hydrochloric acid. So it's a slightly complicated process, the production of hydrochloric acid in the stomach. So let's go back and take a look at what happens when you take antacid like ranitidine. So we all know that hydrochloric acid is needed for digestion of protein. When you eat steak or fish, you need some pepsin enzyme that can digest the protein. So hydrochloric acid basically activates pepsinogen, which is the inactive form of the enzyme, to pepsin. So pepsinogen to pepsin. That is, pepsinogen is basically the inactive form. That is inactive. And this enzyme that is needed, the active version of the enzyme, it's called pepsin. Many of you are aware of this. So that activation takes place in the presence of hydrochloric acid, and then that pepsin is used to break down some of the, or digest some of the protein in the stomach. So too much acid is not good for our stomach, so that can lead to, as you can see here, too much acid can corrode the stomach and lead to ulcers. So when a person suffers from peptic or intestinal ulcers, they usually take ranitidine. Of course, there are other more specialized drugs. So what happens when a person takes ranitidine? So let's say that is my ranitidine pill. So with a capital R. So the ranitidine goes and basically blocks that site. Blocks the H2 receptor site, we call that H2 receptor. So ranitidine goes and blocks that hydrogen or a H2 receptor site on the surface of the parietal cell. So the histamine can no longer bind to the parietal cell. You see what's happening? So once a person swallows the ranitidine pill, it simply goes and blocks the H2 receptor site on the outer surface of the parietal cell. So the histamine is no longer able to bind or send messages to this receptor site. So parietal cell is not able to produce hydrochloric acid or excess hydrochloric acid. Right? There is still some hydrochloric acid, but definitely the binding of ranitidine to that H2 receptor site prevents the histamine from bonding to the parietal cell. As a result, there is not much of hydrochloric acid produced in the stomach. So that's how. So if I have to summarize it, I can say ranitidine simply blocks H2 receptor site, and precisely for this reason, since this drug blocks the H2 receptor site on a parietal cell, they're also called as H2 receptor antagonists. It's like the villain. So ranitidine is like the villain if you consider the receptor site and histamine as two lovers. The ranitidine is like the villain that is separating the two and preventing the blossoming of love, which here is the production of hydrochloric acid. So that completes the video on working of ranitidine or Zantac.